And here we are on the final countdown, dealing with the top 3.
Number 3. The horizon. Ships on the ocean or tall Chicago buildings viewed over Lake Michigan disappear bottom first. And you can see the sunset twice if you watch it lying down and then quickly stand up. The simple fact is, if the Earth were flat, there wouldn't be a horizon beyond which things could disappear. So from across Lake Michigan, you'd be able to see all of Chicago, as well as the Rocky Mountains.
Now, what's interesting about this video is it was done December 28th, 2012. So good 3 years or so before the whole flat Earth thing. And the picture of Chicago from the other side of Lake Michigan taken by Joshua Nowicki. Of course, you guys know the rest of the story as far as that goes. Now, in the video that I did with Rick Hummer, our primary objective was just to debunk the weatherman who said that what you're seeing is a mirage. That was our objective. That's the title of the video. We are going to prove that what you're seeing from the other side of Lake Michigan is not a mirage. And I believe we successfully did that. We showed it's not a mirage. Now, of course, we had, hopes that we would be proving something with regard to flat Earth. Wasn't our objective, as stated before, during, and after. But yes, we were both trying to see if there was evidence that the Earth is flat, or what would end up proving as a globe. Now, of course, when many people looked at the footage, the first knee-jerk reaction was, Skiba just proved the Earth's a globe. Congratulations. Hey. Yeah, well, I did a bunch of other tests and have yet to publish things that I still have incomplete, which I probably never will get to anyway, but it doesn't really matter. Whatever I put out there, people are just going to have a million yeah-buts anyway. But here's some of the things that I put out before regarding the issue of atmospheric lensing and how I don't need a curve to make the lower portion of cities disappear. It's important to point out that before we even did our trip in June of 2016, that the weatherman actually did a special on the 1 year anniversary of being sent that picture from Joshua Nowicki and doing that initial report on it. He actually debunked himself. He had already done a video basically saying, okay, it's not a mirage, it's something else. Here's the video that he did in April of 2016, 1 year after the initial story.
All right, 1 year ago to this very night, I received this picture. After showing it a year later, I received email after email after email saying that this was not a mirage. So I climbed the dunes myself to see this phenomena and spoke with the experts to settle this Skyline skepticism. So technically speaking, this pic is looming. It's not a mirage, but that's all semantics. It's all atmospheric refraction. Now, we have a lot of web extras with this story. Log on to abc57.com after this newscast. You can see the time lapse, a short lecture by Dr. Rennie, and how you can calculate how far you can see to the horizon based on your location. Reporting live, I'm Chief Meteorologist Tom Coombs.
And you can learn more about the story from the Channel 57 News website under the Skyline Skepticism, the Lake Michigan Mirage story. So what's really bizarre about this story is you've got Joshua Nowicki, who's a semi-professional photographer, and this weatherman looking out there, and they are seeing distortions. I mean, no question, the weather causes atmospheric distortion, and it does cause mirages. But they seem to be of the opinion that the more buildings of the city that you can see clearly, the more we're dealing with atmospheric conditions. And yeah, look, I'm not a meteorologist. I didn't go to school for any of this stuff, but common sense says to me, anyway, that no, the default is probably to be able to see the city. But when we can't see the city, it's because of atmospheric conditions, atmospheric blocking, atmospheric, distortions causing mirages and things like that. So in other words, we should be able to see it. It's when we can't see it that we're dealing with atmospheric conditions. These guys are saying, oh, when the conditions are just right, the atmosphere acts like a lens. And I pointed out in the video there in the text I put on the side, keep in mind the phrase atmospheric lensing and looming. And so here we see the difference between looming on the left and a mirage on the right. Both of these pictures were taken by Joshua Nowicki on April 13th. And he's got, you could actually watch on that website, they got a time lapse showing, he over a period of time, Joshua kept the camera pointed towards Chicago, and sometimes you can see it, sometimes you can't. And I contend that when you can't see it, it's because of the atmospheric blocking and various conditions obscuring it. When you can see it, it's when you have a lack of atmospheric conditions. I don't believe we're dealing with some kind of magic where it's going, beaming the city over the curve so that we can see it perfectly. Now, looming is defined by the dictionary.com website as a mirage in which objects below the horizon seem to be raised above their true positions, and also to appear indistinctly coming into view in indistinct and enlarged form. Well, the indistinct part's tripping me up here because everything was very distinct. I mean, straight lines, perfect. And interestingly enough, speaking of the dictionary definition of looming, I showed dictionary.com earlier, but I also looked up the definition of looming on Wikipedia and found some interesting things here that may support what I just said. For instance, this last paragraph here says, there is a different type of mirage that is also described as looming, in which distant objects appear much nearer than they actually are. It is explained in the same way as the image of the ship, except that the image is not inverted. The density variations may also act as a magnifying glass. And if you click on the link above where it says, for the atmospheric refraction phenomena, see looming and similar refraction phenomena, you come to this page. And it says, while mirages are the best known atmospheric refraction phenomena, looming and similar refraction phenomena do not produce mirages. Mirages show an extra image or images of the miraged object, while looming, towering, stooping, and sinking do not. No inverted image is present in those phenomena either. Depending on atmospheric conditions, the objects can appear to be elevated or lowered, stretched or stooped. These phenomena can occur together, changing the appearance of different parts of the objects in different ways. Sometimes these phenomena can occur together with a true mirage. And it goes on to say, looming is the most noticeable and most often observed of these phenomena. It is an abnormally large refraction of the object that increases the apparent elevation of the distant objects and sometimes allows an observer to see objects that are located below the horizon under normal conditions. And they have this picture here, and if you click on that, it says the distant boats appear to be floating in the sky as a result of looming and other refraction phenomena. I'm going to have to disagree with that. I think all that's happening right here is you're actually seeing the ships where they are. Now, they may be enlarged a little bit due to refraction and magnification and whatnot, but they're not floating in the sky. I have seen with my own observations using the Nikon Coolpix P900 that there's what appears to be the hard line of the horizon on water, and then there's a miraged horizon beyond that you can actually watch boats go right out into. And you've seen that online before with the Red Boat, for instance, that video done by Lori Ferrari. And I also did a similar video where I went to Florida and I was visiting my family. We went out to the beach, and it was a fairly clear night, although it looks a little bit hazy in this video here. And I was watching ships go out to sea. And these ships right here that you see on the screen started out right beside me, and I watched them leave the dock and go all the way out to where you see them right here. And I just kept the camera on them and just followed them out there. You'll see the hard line right here of the water, and that's about 2 to 3 miles out, I'm guessing. But if you just keep watching, they'll go beyond that line. You'll see them going out beyond the hard line right there. And here's a shot where they've gone way beyond that line. They're out at between 4 and 5 miles right now. And looking at the curvature chart, at the water level, you should be missing 10 feet of the ship. And my camera was just about 2 to 3 feet at the most above water level, and I don't see anything missing there. So I believe all that's happening right there is just like when you look out at cars driving on the highway and it look like there's a big puddle up ahead, but it's not. It's just miraging on the ground, making it look like water. And so in this case, out to sea, it blends in with the sky and it gives the appearance of losing the horizon, but you haven't. The ships will just keep going out on that water. It's not a mirage, it's not looming, it's not anything. It's just ships going straight out to sea on a flat level surface. Now, I need to point out the fact that there is a lot of water in the atmosphere. And biblically speaking, it's also kind of interesting that the heavens, and we know that there are multiple heavens. Many say that the first heaven is where the birds fly, and the second heaven is space, and third heaven is where God is, and perhaps there's even more heavens within the heaven that God's in. But the word heaven in Hebrew is shamayim. And if you look that word up, like on Bible.cc, for instance, it's Strong's number 8064, shamayim, heaven. Scroll down, gives you a little bit more definition here from Strong's exhaustive concordance, air, astrologer, heavens. It's a dual of an unused singular, shama, from an unused root meaning to be lofty, the sky as aloft. The dual perhaps alluding to the visible arc in which the clouds move, as well as to the higher ether where the celestial bodies revolve. So it's lofty, it's up there. And so that would be the singular. But it's like a compound word, because within the word shamayim is the word ma'im, and that's Strong's number 4325, and that's the word for water. And if you scroll down to the Strong's Exhaustive Concordance elaborated definition here, water, wasting, watering, course, dual of a primitive noun but used in a singular sense. Water, figuratively, juice, by euphemism, urine, semen, piss, wasting, watering, coursing, flood, spring. And I believe it was a lecture that was done by Dr. Kent Hovind where I first heard this, but the word shamayim could be understood to mean water in it. And there certainly is a lot of water in the heavens, or what we call the atmosphere. So I went to a few websites. I just did a Google how much water is in the atmosphere, and this is the USGS website, usgs.gov, Science for a Changing World. The USGS Water Science School talks about there is always water in the atmosphere. Clouds are, of course, the most visible manifestation of atmospheric water, but even clear air contains water in particles that are too small to be seen. One estimate of the volume of water in the atmosphere at any one time is about 3,100 cubic miles, or 12,900 cubic kilometers. And it goes on to say that if all the water that's in the atmosphere were to rain down at once, it would cover the globe to a depth of about 1 inch. And this is confirmed on a number of websites, but I'll just show you one more just for the sake of argument here. This is the Y Files, the science behind the news. They have an article, How Much Water is in the Atmosphere. It says, at any moment, the atmosphere contains an astounding 37.5 million billion gallons of water in the invisible vapor phase. This is enough water to cover the entire Earth, land and ocean, with 1 inch of rain. And, of course, goes on to talk about that as well. So, yeah, there's a lot of water in the atmosphere. I think we all kind of just know that, but I don't think we've ever really thought about what that means. And so I'm thinking if the atmosphere, especially over water, is made up of zillions and zillions of tiny convex drops of water, then collectively perhaps they all combine to make one big convex lens, in which case it would act like a magnifying glass. Okay, so with that in mind, let's look up some websites dealing with the refraction of light. You might see a graphic, something like this, showing light bending downward. And here's your typical graphic showing how light rays entering some sort of medium, like in this case water, refraction causes the light to bend downward. Now we've all seen pictures of, a pencil or something in a glass of water, and how not only does refraction bend the image downward, it also magnifies it. I'm going to say that again. Water causes refraction, bending the image downward, and magnifies it. So this is important now. But they have sort of an unusual, although I would say very common, view as to how downward refraction is being used to allow us to see things up, over, and around the curve. And while I was looking at the Channel 57 News website, I found some raw footage, it looks like, of the conversation the weatherman had with the optics expert at that university. Check this out.
One way that can happen is called looming, and this is a situation where cases where you can see objects in the distance that would normally be obscured by the curvature of the Earth. So as an example, in the next picture we'll show a picture taken from a person standing on the shoreline of Lake Michigan, and he can see almost to ground level Chicago, whereas normally you wouldn't be able to see that far because of the curvature of the Earth. So what's happening in this case is, especially this time of year, Lake Michigan is much colder than the air above it, and that has the effect of cooling the air just above the lake. And so now you have the case where the index of refraction is increasing with the height above the lake, and this has the effect of bending light rays back down so that they can get around the curvature of the Earth and be seen by an observer standing on the shoreline here in Michigan.
Now, prior to doing this research, I probably would have just shook my head and agreed with everything he just said. But now that I've begun to question the shape and nature of the Earth and look at it from a different perspective, this seems to me like an ad hoc theory. It seems like they start with the premise, well, we all, of course, know the Earth is a globe, it's a sphere, and Chicago's too far away for us to see it, so therefore this must be what's happening. And they create a nice graphic and take the principles that we know and understand about refraction and how the atmosphere plays into all that, and throw together again, it looks to me now like an ad hoc theory to explain how the city is thrown up over the curve so that we can see it on the other side of Lake Michigan. That's what it looks like to me anyway. All right, let's continue.
So is all this under Mirage and then looming is under Mirage, or what are the semantics of looming versus Mirage?
Okay, well, that's all. I guess that's all in the details of the terminology. From what I understand, technically, I think Mirage has to have an inverted image, whereas there are other atmospheric effects such as looming or towering that are purely displacement, and you don't necessarily have to have an inverted image in order for refractive effects to occur in the atmosphere.
So they would all fall under the category of atmospheric refraction.
I guess that would be a good thing to say. Yes.
Okay, so again, this is their graphic. According to them, we know the Earth's a ball, so therefore this is the way it's working. Chicago's over here on the left, we got the curve of the Earth here, and the light rays, which would normally be going straight across, have to be bent due to the atmospheric lensing, the density of the atmosphere and whatnot, causing the light to refract downward, basically just conveniently enough over the top of the bulge of the curve so that we can see it on the other side. Now, here's where I would differ with this whole idea. Again, just sort of flipping the board. Let's just say we don't start with any preconceived notions of the Earth as a globe. Let's entertain for a moment the completely absurd notion that water is flat and it always seeks its own level. And we're looking across a flat plane of water, 46 miles across. Check this image out right here. Now, I caught this image shortly after Rick and I returned from our trip across the lake. We grabbed a bite to eat, and then we went out to the beach, and it was still clear out, so we got the camera out and looked 46 miles across the lake to see this right here. This image is extraordinary. Okay, the boat right here, I'm going to guess, is less than a mile away. And I base that because these people walking in front of the camera here are walking across some rocks that sort of jut out and kind of fence in the harbor area. And they are only about a quarter of a mile away from where we were when I shot this. I shot this image from right about here. This is where we were looking across, and this is the area right here where those people were walking. And the boat, as you could tell by the size of the people on the boat, wasn't too much further beyond that. So maybe a half mile to a mile, or at the most, I would say, away from where we were. All right, now when I was headed back to Chicago to catch my flight, I snapped this picture of the Willis Tower. And this is, if you go on Google Earth, this is right about the area right here where I believe I was when I took that picture. Looking across, it's only about 0.6 of a mile. So I'm just a little over a half mile away, and look at the size of the tower as compared to the car that was diagonally in front of me. We were looking at the Willis Tower from this direction right here when we were on the other side of the lake. Now, okay, so let me slide the car over and shrink it down to the appropriate scale beside the boat. Do you see something rather interesting here? This building is significantly magnified. The image on the left shows the size and scale of the building next to a car at 0.6 of a mile away. The image on the right shows the same building and the same car with a boat at 46 miles away. The atmosphere really is acting like a lens. What type of lens? A convex lens or a magnifying glass. So I'm going to suggest this is what's happening. The atmosphere is acting like a lens, which magnifies the city, brings it up a little closer, and as it does so, we start to lose a little bit of the bottom of the buildings, and perhaps due to the density in the atmosphere, there's additional refraction that takes place that makes it drop down even more. Is that what happened? Let's look at it from another angle here, from the side view. I'll bring our graphic back in of refraction. Let's go ahead and orient the graphic so it better represents what we're looking at here. I'll angle the light rays to show the density of the air here causing the refraction, and bring our lens in so we can magnify the city. It brings the city up, and as it does so, we start to lose a little bit of the bottom of the city, and perhaps either due to the magnification or due to additional refraction, maybe it is dropped down a little bit more, and this is what we end up with. Huh. Just like we saw. Now this is a still frame from the half-hour video that I did, and the numbers you see there are all based on the numbers that Tony was giving me based on his device. His device said it was 37 nautical miles, which is 42.6 statute miles, but when you plot the same exact location that we were at, the exact distance you get on Google Earth is 46 miles. So you basically add about 4 miles to all the numbers that you saw in the half-hour video. But here's where it gets interesting, at least to me. Both of these pictures were taken with the same camera. Now, if you remember from the half-hour Chicago Skyline video, I was saying I can see Chicago. We're about 42 miles away. I can see it. The problem is trying to get the camera's having trouble focusing on it because it's moving up and down and it's so zoomed in. But I can totally see it. Rick was not zoomed all the way in. He was using my camera, the Nikon Coolpix P900, but he was only zoomed in about halfway when he grabbed the shot above. Now I know that when I got the image below, I was zoomed all the way in. And so some people may point to one of my videos where I was actually debunking myself. If you remember that NASA video showing the Earth and the Moon, and the moon was going in front of the Earth. So I did a little experiment where I used a baseball as a moon and a larger ball as the Earth. And I got at the end of a long hallway with my Canon 70D and zoom lens, and zoomed all the way in on it. And this was the image that I captured doing this experiment. There's the NASA image on top, and there's my image. And so, you know, just by virtue of the lens, it does magnify the distant object to make it look proportionately large to the object that is closer to you. So is that what's happening here? Well, both these images were shot from the harbor area here. The red line at the top is where we were in the boat. We're just about to depart when I asked Tony to stop, and I got the camera out to shoot Chicago. And the lower red line is where we were on the beach when I took the picture on the bottom there. So, and the distance between those two locations is less than a quarter of a mile. So it's negligible. We're still looking about 46 miles across either way. Now, here's the shot from the beach before I zoomed in. Now I'm zooming in, zooming in, zooming in, and I'm going to stop it right about here. That's about halfway on the zoom, and I believe that's where Rick had the camera set when he took the picture above. Based on the size of the building right here, I'm going to guess that he was about halfway. Alright, so let's go ahead and continue the zoom. And this is zoomed all the way in. The Nikon Coolpix P900 has an 83 power optical zoom, and that little punch in after that was the digital zoom afterward. It has a digital zoom that goes beyond the 83 power. I did not go all the way in with that. I just punched it a little bit because I wanted to frame it with the ship right there. So that's 83 power plus. So gonna guess it's probably the equivalent of about maybe 90 power zoom or so right here. Now let's bring the picture in from the halfway zoom, and I'm going to go ahead and bring our car back in and slide the picture in from Chicago, and I'm going to scale the car to the appropriate size to the boat right here and go ahead and slide the car over to the building. So this is what the car and the building look like at half zoom. So let's try something else here. I'm going to unfreeze the video and back it off so it goes backwards, and we're zooming out back to the shoreline, and now I'm gonna bring it forward again, and let's see, right about here is where we have some fairly decent resolution where you can still make out the building. I'm going to zoom in here with the computer. This is a computer zoom right now on this still image, and I'm going to bring the other image in from the half zoom and scale the car over to the digitally zoomed in image of the almost completely zoomed out shot. And so you got three different zooms here. One almost completely zoomed out, one zoomed about halfway on an 83 power optical zoom lens, and the one on the right, of course, all the way zoomed in with a little touch of digital zoom on top of that in the camera. And when looking at these images compared to the one on the left, which is just shot with my iPhone, I got to tell you, it looks like it's being magnified to me. Especially when you consider the fact that that building is like 45 miles away from that boat. It's 45 miles away. So, it looks like there's some serious magnification going on here. And, you know, some of that could be due to the lens, I'll give you that. But I also know what I could see with my own eyes. Now, I understand you may not want to take my word for it, so all I can say is go up there and do it yourself. But based on what I saw with my own eyes, as well as what the quote-unquote experts had to say regarding how the atmosphere can act like a magnifying glass, I'm still going to go with it as being magnified. Again, you can go out there and test it for yourself. But remember, let's just go back and hear from the experts once again about what they say is happening.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here, just maybe now you can just see the top of the Sears Tower, and if our simulated temperature inversion moves into place, hopefully now you can see pretty much all of Chicago,
see all the lower buildings,
including what's at ground level.
So the atmosphere really is acting like a lens.
Yes.
So the atmosphere really is acting like a lens, according to the experts. Now, you guys don't need to go out and spend tens of thousands of dollars to get that pretty piece of paper to hang up on the I Love Me wall and put letters after your name so that you can call yourself an expert. You can be an expert with what you see here on the screen. Yep, believe it or not. Go to Walmart, and your advanced degree in atmospheric lensing technology will cost you just a couple dollars. You can get a 2x power lens for about $1.85, I think, at Walmart. Get yourself some Scotch tape. Then if you look in the description below, you'll see I put a PNG file of a city. You can print that up, cut it out so it looks something like this, what you see on the screen here. then find a table and a chair. And okay, you're going to bend the paper so it looks something like this. Tape the lens to the table, get a chair that's about the same height as the edge of the table. Put your iPhone on the end of the chair, and the chair will act as a dolly, so you can just kind of pull the chair back. And looky here. Look what happens with atmospheric lensing. Wow, isn't that amazing? And you didn't have to go to college either. Now, you can get in a boat and drive to Chicago, and wow, look at that. Now, let's compare. See? Look at this. This is how much of the city was lost simply due to atmospheric lensing. Now remember, the experts, the guys that spent tens of thousands of dollars to get advanced degrees in this stuff so that people would recognize that they're smart, they told you the science really is that of a lens. And of course, we have to deal with the Toronto Skyline, right? You've probably seen the meme being passed around on Facebook and everything, showing the lower portion of one of the tall buildings there in Toronto being missing, and they're saying, see, this is proof of the globe. And you start seeing videos like this one.
Another way to demonstrate the curve is with distant city skylines. A good example is the city of Toronto, viewed from across Lake Ontario. The city is dominated by the distinctive CN Tower, currently the third tallest tower in the world at 1,815 feet. There are many pictures online of the Toronto skyline, viewed from Niagara-on-the-Lake, New York, 30 miles away. With the debunk calculation, we see that 486 feet of the tower, or about 26% of it, should be hidden behind the curve of the Earth from that distance. And this is exactly what we see, as you can easily tell when compared to an image of the full tower at the same scale. One example they use is the Chicago skyline seen from 60 miles away across Lake Michigan. At a viewing height of 6 feet, we calculate that 2,166 feet should be below the horizon at 60 miles. So they are right that the entire city of Chicago should be completely hidden. And it is hidden nearly all the time, but sometimes it can be seen from that far away due to a type of atmospheric light refraction phenomenon called a superior mirage. A superior mirage is caused by colder air below warmer air, which bends the light around the curve of the Earth. This event sometimes makes the news for the very reason that it is a rare occurrence.
Now, in most social settings, such a continuous condescending tone would likely get you punched in the face repeatedly, but beyond that, I have to remind you of the response that another former weatherman gave regarding the whole idea of this being a superior mirage. Let me play that for you again.
See, what they're not showing you is the ridiculousness of how high this mirage would be. But I'm showing you what it is right here. And remember, since we saw the water line the whole way, okay, let me show you how that would look. The water was up there with it too. So from the guy that took the camera all the way out, okay, we're supposed to believe that there was a continuous 5,200 feet inversion that suddenly just happened to come down to the guy right on the edge perfectly, so that he saw, when he looked out, like a perfect skyline across there of Chicago. So again, here are the steps. You have the regular right side up image, then you turn it upside down. It has to happen on a Mirage, guys. This is the typical one you see out at sea, this upside down one right here. Now what they're claiming is it was so deep, this layer here, this inversion, that it had enough to rectify back up once again, 5,200 feet. So if we were to, you've probably seen, look up superior mirages. You'll find like ships that will be upside down looking, one on top of the other. That's the typical superior mirage, which you would see right here. Okay? That would be a minimum of 4,800 feet. But since the image was not inverted and right side up, which really tells you you're looking at Chicago, you're not looking at a superior mirage. Okay? It requires 5,200 feet. I implore you, please call any National Weather Service office and ask them if they've ever seen an inversion from the surface up to 5,200 feet. Okay? They're going to laugh at you.
Now let's go back to Captain Baltard.
You can tell that it's a mirage because there is lots of distortion. The Willis Tower on the left is clearly elongated. And also, there are videos of this same view that show the buildings dancing around, changing shape, and even disappearing. Even though this is a mirage, the bottom parts of the buildings are clearly still obscured from view, just as we expect. If the Earth was flat, you could see the buildings on any clear day, not just rarely when the conditions are right for refraction. Flat Earthers use these rare events to try to prove the Earth is flat, but that makes no sense. It's called cherry picking, a favorite trick of all types of science deniers. You don't get to pick the anomalies that seem to agree with your views and ignore the common observations that don't, and still call yourself an honest investigator. That is intellectually dishonest.
Now let's see who's going to pick and choose what common observations they're going to accept and or ignore. Here's an interesting video I saw online regarding a full day time lapse revealing superior mirages. Now this is quite extraordinary actually. This is from skunkbayweather.com, September 7th, 2012. Notice the buildings and the shoreline here over on the left. Keep your eye on that. Just watch that, and the mountain in the background. Everything's pretty cool. You can see pretty much everything there, but as the day progresses, and we are now at 9:30 a.m. and it's 59 degrees, 60 degrees, it's getting warmer, the temperature is changing, we start to see some miraging take place, right? It starts to distort things a little bit. Ooh, look at that. The water seems like it's getting higher, and we're losing buildings, and we're losing the beach. Here it is now, noon, 63 degrees and climbing. Uh-oh, there it goes. Oh, there it is again. Oh, it's all miraged. Huh, it's all distorted. Sometimes you see it, sometimes you don't. The default is to see it, though. That's the point. The default is minus distorting atmospheric conditions, you would be able to see everything clearly. But due to different temperature variations and density in the atmosphere and whatnot, sometimes you can see the whole shoreline and the buildings, sometimes you can't. But the magic trick is not in being able to see it. It's what is taking place that obscures your ability to do so. Look at this. And the mountains in the background shrink and expand and everything too. I would suggest that you hit pause on this video and rewind and watch that back and forth a few times. In fact, I'll put the link in the show notes below because I sped this up. I made it only 2 minutes long instead of 4 minutes long. So you can watch the whole thing in a little bit slower motion there. But I mean, look at the comparison right here, just in these two images right here. The one on the right at 5:44 p.m., 63.5 degrees Fahrenheit. Can't really see anything on the left shoreline there. And on the left at 9:43 a.m., when it was 59.5 degrees Fahrenheit, we can see the shoreline, we can see buildings, trees, all kinds of stuff. So, I mean, either this lake is, filling up and draining so that the water level is higher or lower, or it's due to atmospheric lensing and distortions, refraction, and all that good stuff, causing us to not be able to see it at certain times. I think that's exactly what's going on Lake Michigan. And again, based on that imagery that I saw looking 46 miles across versus 0.6 miles across, I really do believe that, just like the experts said, the globalist guys, these are people who believe in the globe now, they are the ones that said, hey, the atmosphere really is acting like a lens, and they put a lens in front of the camera to show how it works. So I'm just doing what they're doing. I'm using the same logic that they're using, the same science that they're using. And, science is all about testable, observable, and repeatable data, right? So to alleviate the problem of distorting the edges because the magnifying glass ring is too small, I went on Amazon and I got these plastic magnifying sheets and came up with another way of doing the same thing. using the sheet right here. Set the city up, a little cutout of the city, and now I've got the big magnifying glass sheet. Bring the camera right up to the lens. See, that's the normal view of the city. Now let's back up again.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here,
The atmosphere really is acting like a lens.
yes.
Atmosphere really is acting like a lens, and this is how much of the city is missing due to the lensing effect, the magnification of the atmosphere. You're missing, a good portion of the city just by pulling my iPhone back on a 3-foot long desk. That's how much I lost of the city. And as with any scientific experiment, you always try to improve upon what you did before. So I got some foam core, made a little housing for the magnifying sheet, and pasted the city on the back there. And I made it as 2 separate pieces so that I could flex it as necessary, because I think that there are different types of atmospheric conditions that would allow for more magnification versus less magnification. So in this scenario, you have more magnification, and in this one you have less. And for this one I decided to put the Toronto skyline into my little box here. And let's try it again. Okay, we're all the way up against the glass. Now let's zoom across the lake. And wow, look at that. The lower portions start to disappear. Now let's zoom back in to get a little closer to the one that Captain Baltard was talking about here. And wow, look at this. Here's his image on the right, and here's my image on the left. Missing the lower portions of the city had nothing to do with curvature whatsoever.
Another favorite supposed proof of ball earthers is the appearance from an observer on shore of ships' hulls being obfuscated by the water and disappearing from view when sailing away towards the horizon. Their claim is that ships' hulls disappear before their mastheads because the ship is beginning its declination around the convex curvature of the ball earth. Once again, however, their hasty conclusion is drawn from a faulty premise, namely that only on a ball earth can this phenomenon occur. The fact of the matter is that the law of perspective on plane surfaces dictates and necessitates the exact same occurrence. For example, a girl wearing a dress walking away towards the horizon will appear to sink into the earth the farther away she walks. Her feet will disappear from view first, and the distance between the ground and the bottom of her dress will gradually diminish until, after about a half a mile, it seems like her dress is touching the ground as she walks on invisible legs. The same happens with cars speeding away, the axles gradually getting lower and the wheels vanish until it appears as if the car is gliding along its body. Such is the case on plane surfaces. The lowest parts of objects receding from a given point of observation necessarily disappear before the highest. David Wardlaw Scott says, "This law of perspective meets us on every hand and cannot be gainsaid. If, in a straight line, we look at a frozen lake from a certain distance, we shall observe people who appear to be skating on their knees, but if we approach sufficiently near, we shall see them performing graceful motions on their feet. Farther, if we look through a straight tunnel, we shall notice that the roof and the roadway below converge to a point of light at the end. It is the same law which makes the hills sink to the horizon as the observer recedes, which explains how the ship's hull disappears in the offing. I would also remark that when the sea is undisturbed by waves, the hull can be restored to sight by the aid of a good telescope long after it has disappeared from the naked eye, thus proving that the ship had not gone down behind the watery hill of a convex globe, but is still sailing on the level of a plain sea." Not only is the disappearance of ships' hulls explained by the law of perspective, it is proven undeniably true with the aid of a good telescope. If you watch a ship sailing away into the horizon with the naked eye until its hull has completely disappeared from view under the supposed curvature of the earth, then look through a telescope, you will notice the entire ship quickly zooms back into view, hull and all, proving that the disappearance was caused by the law of perspective and not by a wall of curved water. Samuel Robotham says, "On any frozen lake or canal, notably on the Bedford Canal, in the country of Cambridge, in winter and on a clear day, skaters may be observed several miles away, seeming to glide upon limbs without feet. skates and boots quite invisible to the unaided eye, but distinctly visible through a good telescope. But even on the sea, when the water is very calm, if a vessel is observed until it is just hull down, a powerful telescope turned upon it will restore the hull to sight, from which it must be concluded that the lower part of a receding ship disappears through the influence of perspective and not from sinking behind the summit of a convex surface. Ball earthers will often also quip that if the Earth were flat, then we could see all over it. But this is, of course, ignorant and inaccurate. If you stand on the beach, a plain or prairie, you will find the horizon extends about 3 to 6 miles around you, depending on the weather and your eyesight. The range of the human eye, our field of vision, is from 110 to 1 degree, and the smallest angle under which an object can still be seen is 1/60th of 1 degree, so that when an object is 3,000 times its own diameter away from an observer, it will cease to be visible. So, for example, the farthest distance at which one can see a 1-inch diameter penny is 3,000 inches, or 250 feet. Therefore, if a ship's hull is 10 feet above the water, it will disappear from the unaided eye at 3,000 times 10 feet, or 6 miles. This has nothing to do with the supposed convexity or curvature of the Earth, and everything to do with the common law of perspective. Thomas Winship says, "The horizon of an observer is distant or near according to the greatness or otherwise of his elevation above the surface of the supposed globe. If he stands 24 feet above sea level, he is said to be in the center of a circle which bounds his vision, the radius of which in any direction on a clear day is 6 miles. A local gentleman tells me that he has watched a boat race in New Zealand, seeing the boats all the way out and home, the distance being 9 miles from where he was standing on the beach. I have seen the hull of a steamer with the naked eye at an elevation of not more than 24 feet, at a distance of 12 miles, and in taking observations along the South African coast, have sometimes had an horizon of at least 20 miles at an elevation of 20 feet only."
Do we really see ships going over the curve? Now, if we do, that's going to start to happen at between 3 and 4 miles. I mean, at 4 miles, you should be losing 10 feet worth of a ship. At 5 miles, it'd be almost 17 feet worth of the ship. 6 miles, 24, 7, almost 33 feet, and so forth. So Jaron did a really good video commenting on some footage shot by a woman named Lori Frary, and I'm just going to play a little clip from his video right here regarding the whole issue of boats allegedly going over the curve.
All right, let's take a look at some film now. Thank you, Lori Ferrari, for letting me use this video. I believe she filmed it off the coast of Florida, and she stayed with it a good 25 minutes, and in the description will be the link to the full video. So I'll be pointing out some things as we go along so that we can start to see exactly what's happening. Now, if you look in the background, you can probably see some buildings back there. That is not a mirage, and we'll get into that in a little bit. But a mirage would be distorted. It would have a haze effect or a watery look. And it's also not any kind of superior mirage in which things are lifted up above the water. Those buildings are just the outlines of the buildings that are actually there. So if you start looking underneath the red section of the tanker, you'll see a little white sliver showing up. And if you notice, that is just the reflection from the part of the boat, the bridge, above it. So if it's reflecting, what would it be reflecting on? It appears to be reflecting on air, doesn't it? But we know that's not what's happening. It's actually reflecting off the water, which has taken the exact color of the sky. It appears to be gone, and this is what the ancients saw. They thought the boat went over the curvature or the horizon. But we zoom back in, and there it is. Now you'll notice that little white section is even more pronounced than before. The reflection is getting larger. You also see these high point waves, and you also see that band area that they call the Mirage zone or the Mirage band. And now you can really start to see that that boat looks like it's floating on air, but actually that is water out there that is being miraged by the sun. Same kind of mirage you see at the end of a long freeway or in the desert. That's the same thing you see there. But of course they wouldn't tell you that. So we'll zoom out again, watch that boat. Looks like it almost goes over the horizon there. And we'll zoom back in. And we can see it just scooting along on what looks like invisible air. So if you notice here in the two boxes, right and left, that the wave chops are, which would be 5 to 10 feet high. We know the waves aren't that big. Then you'll also see the black line separating where the water actually is versus where it appears to us to be. Now you'll notice that white bridge reflection is a lot bigger. But by zooming in, we can pick it back up. You'll see now that the white bridge section has almost become the same color as the sky. It no longer has a lot of the markings that it had before. In fact, I think we'll see it here within the next 20 seconds turn into the sky. You'll see the front end of the boat is completely chopped up now. And all that is a mirage. Nothing is floating above where it should be. It does happen on occasion, and that is called a fata morgana. But now you'll see that reflection plus the bridge of the boat has all turned into the same color as the sky. And the boat is almost completely broken up. Zoom out, there'd be no way you'd see that with your own eye. It looks almost as if two ships are moving along out there.
All right, I'll stop there. But this is a great shot right here showing that the boat didn't go over any curve. And it's way out there. And it's going straight out into atmospheric distortion. The density of the atmosphere between the boat and the viewer is getting thicker and thicker and thicker, and it's causing all kinds of atmospheric distortions, and you're starting to get some mirage effects right there. And here's another video by another YouTube channel, God Rules, talking about the same kind of thing with other people sending in footage of ships that they're watching with high-powered camera zooms and telescopes. Same thing. They're not seeing ships disappear.
When the chimneys of the ferries disappeared under the water, I used my binoculars. So in other words, with his eyesight, he looked at this ferry, and when the chimney had gone beneath the water horizon, okay, so it looked like it went over the horizon, as they claim, like, oh, it looks like the ship sailed over the horizon. So it actually went completely under the horizon at normal eyesight, is what he's saying. Okay, so he said it disappeared under the water. I used and then he pulled out his binoculars to look, and the ferry was there again. It popped up again. So in other words, when he looked with his plain sight, the ferry is over the horizon, as they claim. But then he took out his binoculars and looked at it, and there the ferry is. It didn't go over the horizon. You could see the bottom of the ferry. You could see the entire ferry. When it disappeared in my binoculars, so it was continuing to sail away from him. So now he's looking through his binoculars until it disappeared with his binoculars. I switched over to the telescope immediately, and the ferry appeared in its entirety again. So in other words, every time you got a stronger magnification, the ferry's back there again in front of you. It didn't go over the horizon.
So more and more people are doing the same thing. They're taking cameras, they're taking telescopes, they're taking binoculars, they're going to the beach and they're watching ships going out to sea, and the more they zoom in, there it is. Now, there are sometimes issues where the hull is starting to disappear, and I dealt with that a little bit in one of my early videos where I show a possible reason for that could be that it's actually a mirage effect. I'm going to suggest that what we're seeing is the same exact effect that we see when a car disappears wheels first into a Mirage. Now that may be the case, but let's go a little deeper. Now here's the other issue. People who think ships are disappearing over the curve in 3, 4, 5 miles distance, it's got to work both ways. I mean, if we're on a ball, then when the ship is going away from you on the, let's say, the z-axis, going, from you to a point away from you, and it's rolling over the ball in 3 to 5 miles, then you should have the exact same effect looking left to right on the x-axis. You should be seeing ships rolling up to the top of the ball and rolling down on the lateral x-axis. I mean, if it's a ball, they got to be rolling both ways, away from you and side to side. We never see that though. You can go to the beach and do a panoramic shot and put a parallel line over it, and from end to end, and this is a lot more than just 5 miles, there's no perceived curvature here. None. Flat as a pancake. And in fact, these are some pictures I took on the beach at Malibu, California. And I went from there way up into the mountains above Pepperdine University and looked out. And I mean, easily there's got to be probably close to 100 miles left to right. The distance on the horizon there, it's got to be, quite a bit there. Put a parallel line over it, flat. So you can't have it both ways. You can't say ships are rolling over the ball on the z-axis without having the same exact perception on the x-axis. Okay, going back to this picture right here, showing the perception differences when you're zooming in and out. Here's another shot right here. This boat came into view as I was zooming out. Zooming out, zooming out, zooming out, and it rose higher on the horizon. See, when I was zoomed in on him, there's all this space right here from the bottom of the boat to the horizon, and when it's further away, that distance shrinks. So our eyes start playing tricks on us. Now, to better illustrate this, I created this little animation right here, and this represents about a mile worth of ocean. All right, so when you're looking, you can see the difference in how each of these ships looks like it's higher and higher up on the water level. Now that's on flat water, no waves at all. Now let's look at this same animation. I created some waves no higher than the height of the camera. In fact, a few times you'll see the camera go right through the waves, but the wave height was about as high as the camera, which was just a little bit above the water. Okay, so let's look at the same exact animation, this time with some waves. Okay, there's wave, 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 wave. Okay, over the distance here, the cumulative effect of the waves obscures the hull of ships. That's just what happens with the perspective. As the ships get higher and higher up on the horizon, as you get further and further away, and you have the compounding of the waves over that distance, it's really easy to see how you end up with the illusion of ships rolling over the ball when it has nothing to do with that at all. This is a flat plane. Here's the two pictures side by side, with flat water with no waves and then with waves. In both cases, the more distant ships rise up on the horizon, but in the picture on the right, you have the waves obscuring the hull, and over the distance it accumulates, so you lose more and more of it. The other big problem with the ships going over the curve argument is what happens to the horizon when you go up and down on the y-axis. When you go up on the y-axis, the horizon doesn't change. Now, let's assume we're looking at eye level right there, and the horizon's right across our eye level. When you rise up on the y-axis, the horizon stays at that same level. Well, maybe it's hard for you to see in this animation, so let me do more of a basic one right here. Here's the horizon right here. If I go down, it stays the same on a plane. And if I go up, it stays the same on a plane. That cannot happen on a ball. If you saw ships roll over the curve on a ball like this, the horizon's right there. The only way you're going to see that ship is to rise up on the y-axis, but when you do that on a ball, you lose it. Now, here's a more practical example. Just watch cars go over a hill. Get down on the ground. This is my iPhone. I put my iPhone on the ground. I'm watching cars drive by. There's a nice truck right there. They're about to go down a hill. And now here's the horizon right here. This is, the horizon to my camera. And if I want to see those cars, I just have to rise up on the y-axis. Now, I didn't keep it all steady right there. So as the camera comes back to pretty much the same level that the eye level of the camera, as it were, you see the distant horizon right there is the same. It's exactly the same. Now, again, that was sloppy because I was just doing it with an iPhone, and my hands didn't keep it exactly the same. But if you were to rise directly up on the y-axis with a camera on a tripod or a crane or something like that, you'd have the same exact thing that you observe anytime you've flown in an airplane. Doesn't matter how high you go, that horizon just follows right up with you outside your window. When you're sitting on the flight line, you look out, there's a horizon at a certain level, and when you fly up to 35,000 feet, that horizon stays at the same level. That cannot happen on a ball. On a ball, when you rise up on the y-axis, there's no way the horizon is going to rise with you, especially if you think ships rolled over that curve in 5 miles of distance. If you lost, 20, 30 feet of a ship disappearing over the curve, then just like the example of the cars, if you want to see those cars again, you got to rise up on the y-axis and look down at the ever-increasing slope of the hill to watch that, truck or car or whatever continue down the hill. The same thing should be if you're watching ships disappear over the ball on the z-axis in front of you, in 5 miles distance, and you're losing 20, 30 feet worth of the hull, then you should rise up on the y-axis, look down the ever-increasing curvature of the ball to see that ship racing away on the curve. But that doesn't happen. You see ships go away from you on the z-axis, but there's no indication of the same exact curve on the x-axis, and when you go up on the y-axis, the horizon pops up with you. That should not be if we're on a ball.
The distance of the horizon, or vanishing point, where the sky appears to touch the earth and sea, is determined largely by the weather, and, when that is clear, by the power of our vision. This is proved by the fact that the telescope will increase the distance of the horizon very greatly and bring objects into view which are entirely beyond the range of vision of the unaided eye. But as no telescope can pierce a segment of water, the legitimate conclusion we are forced to arrive at is that the surface of water is level, and that therefore the shape of the world cannot be globular, and on such a flat or level surface, the greater the elevation of the observer, the longer will his range of vision be, and thus the farther he can see.
I've been looking into the topic of this video for a while, and I really wanted to introduce the concepts of angular resolution, visual acuity, and diffraction as they apply to the horizon, so that these laws of physics, light, resolution, and perspective can be taken into account and hopefully further developed in order to better understand our Earth, and also to help dispel some of the tired old myths of ships and buildings disappearing over the edge of a ball Earth. Now, mainstream science teaches us that the horizon is the edge of a ball Earth as it curves away from us, because ships disappear bottom first when they sail over this edge. What's funny to me is that their argument of ships going over a ball Earth is just as silly as falling off the edge of a flat Earth. It is a very childish argument, especially in today's world where we can pull objects back into view with a telescope or zoom camera, not to mention the fact that if you ascend in altitude, you can clearly see that a ship or building is not over the curve of a ball. It was simply out of your view due to perspective and the angles of light propagation when you're at a lower elevation. From a higher vantage point, your eyes can clearly see that the water or land is completely flat. There is no curve or edge that boats are sailing over. Again, it is a silly assertion, yet it is one of the main pillars of the ball Earth theory. In this video, I will introduce the concepts of angular resolution with a basic explanation, and then I will show another short clip of MIT professor Dr. Walter Lewin in his Physics 3 course, where he teaches these recognized laws of physics that we can test and observe. This is basically judo, where we are using their own scientific admissions to form a logical explanation of why we observe what we observe, and this in stark contrast to how groups such as NASA interpret the same observations. The survival of the ball Earth theory necessarily relies on NASA images and other space claims. Otherwise, their theory has only silly stories such as a spinning, orbiting ball Earth and non-existent curvature, or the direction of toilets flushing and boats going over the edge of a ball, none of which is observed by the average individual. So to begin, what is angular resolution? Angular resolution describes the ability of any image-forming device, such as a telescope, microscope, camera, or the human eye, to distinguish small details of an object. It is the minimum angle needed so that an instrument can discern resolvable detail, and it represents the resolving power and precision of optical instruments, which includes the eye. This angle is created at the eye or the lens, and it is based on the diameter of an object and that object's distance from the observer or the device. This angle determines the size of the image that is projected onto the retina. So, once an angle is small enough that it reaches the angular resolution limit, no image can be resolved on the retina, and basically the object disappears. The formula to find the angular resolution of the human eye, or any image-forming device, is the constant of 1.22 times the wavelength of light divided by the diameter of the lens aperture or entrance pupil. Once you figure out the angular resolution of, say, the human eye, you can then determine how large or how far away an object must be for you to be able to resolve it. In other words, for you to be able to see it. This is the limit of eyesight, or the resolving power of a telescope, camera, or microscope. Anything beyond this limit cannot be seen. A shorter distance and larger diameter of an object equal a larger angle at your eye, thus easy to resolve. A longer distance and smaller diameter of an object equal a smaller angle, thus difficult for your eye to resolve. The size of the angle is also what gives us perspective. Objects do not physically shrink in size as they move away from us, but the angle in our eye gets smaller and smaller, which is what allows us to determine that it is moving further and further away. For objects coming toward us, the angle will get larger and the object will appear to be larger on the retina. This is an important part of perspective. This is how we distinguish objects moving away versus coming toward us. The angles also help us determine the size or distance of any given object. Visual acuity is another closely related term that means clarity of vision, or the limit of one's eyesight, and it is a measurement of the angular resolution of the eye or the device. The generally accepted value for the angular resolution limit, or visual acuity, of the human eye is about 1 arc minute, which equals 0.02 degree. This means that at a distance of 1 kilometer, the human eye can resolve an object that is about 30 to 60 centimeters in diameter. Beyond this, the angle formed in the observer's eye gets smaller than 1 arc minute, and the object will blur and then finally disappear altogether. And here is another quick explanation of angular resolution by MIT professor Dr. Walter Lewin.
So in the remaining 5 minutes, I want to address the issue of the angular resolution of your own eye. You can now calculate what the ultimate angular resolution is of your own eye, because you can estimate what the diameter is of the pupil, the opening of your eye. 3 millimeters, maybe 5 millimeters, a little bit larger at night when it is dark. Pupil opens up, but we can calculate what this is. If I take 4 millimeters, so I put in for A 4 millimeters, and if I take lambda 5,000 angstroms, it's not an unreasonable value, then I find that the best angular resolution of a human eye is half an arc minute. Cannot be any better. There's just no way around it. You're always stuck with the diffraction limitation. I think, though, that most of you will not be able to see with an angular resolution of 1 half arc minute. Most of you are probably in the domain of 1 arc minute. It's a little larger than diffraction limited, but it's very close to that. That is 30 arc seconds. That is 600 times worse than Hubble Space Telescope. When you think of diffraction, it's really an incredibly fascinating thing. Because what does diffraction actually means? That it is a limitation that is put upon us, on everyone. Also God. No one can bypass diffraction. No matter how hard we try, we can never undo our chains and handcuffs that are imposed upon us by diffraction.
And he's definitely not a flat earther. He obviously believes in the Hubble telescope. The main reason I want to introduce these concepts is to demonstrate with logic that there are scientifically proven and verifiable factors that determine how far we can see with our own eyes and with telescopes. Angular resolution equations are used by NASA, astronomers, and scientists to determine the resolving power of the human eye, cameras, microscopes, and telescopes, including the Hubble Space Telescope. So, when people say, if the Earth was flat, then we should be able to see Europe across the ocean, there are scientifically proven laws of light, diffraction, resolution, and perspective that render this statement foolish. Due to the resolving power of our eyes and even the most powerful telescopes, we could never possibly see across an ocean that is thousands of miles in distance. It is impossible due to the laws of physics, due to the physics of the angles, not to mention the additional limitations of diffraction. Again, it is a silly statement that we should be able to see across the ocean if the Earth were flat. However, the mistaken or disingenuous conclusion put forth by the so-called scientific community, in spite of these scientifically proven and accepted limitations on light propagation and resolution, is that the reason we can't see across the ocean is because we live on a spinning ball. Do you see the trick that they're playing? It is like telling little children that a guy on a sleigh in the North Pole brings them presents on Christmas. It sounds outlandish even to children, but they don't know any better, and they don't actually see the parents leaving the presents, and they are given this story by the authority, so they believe it. In our case, we have a knowledge gap, an unknown, because we can't see across the ocean, or we see ships and buildings disappear bottom first as they get further away, so we look to supposedly qualified authorities to study these issues for us and provide reliable explanations. For hundreds of years, the scientific authorities, now the space agencies, have both knowingly and unknowingly filled this gap with their own cleverly constructed explanations, and most people just accept their models without researching or using reason and logic. If people did think about the issues critically and logically, they would see that the authority is giving us beautifully wrapped presents and putting out cookies for their fictional Santa Claus, in this case, a spinning ball Earth. One way they fill this gap is to use the angular distance of a sky object to invent their model. The angular diameter, or apparent size, is an angular measurement describing how large an object appears from a given point of view. For example, this involves looking at the sky and determining that the sun and moon have an angular diameter of about 31 or 32 arc minutes, which equals a half of a degree. So this is the angle created in our eye or in a telescope, which means that the sun and the moon can be around 31 miles in diameter and 3,500 miles up, or, as the authorities claim, the moon can be 2,159 miles in diameter and 237,000 miles away. And they claim the sun is 864,575 miles in diameter and 93 million miles away. You see, both measurements are correct based on the angle we see from Earth. Knowing the angular diameter or apparent size of a celestial body we can easily invent a model using trigonometry. We could say the sun is 500 miles in diameter and 57,000 miles away, or maybe it is only 5 miles in diameter and 500 miles up. Or, if we wanted to get really crazy, we could invent a sun that is 2 million miles in diameter and 229 million miles away. Of course, if we did that, we would then have to adjust all of the diameters and orbital speeds of the planets and distances, but this should give you an idea of how they have constructed their model, because they are all built on apparent sizes, the angular diameter of lights in the sky visible from Earth. So, relationally, the math works out. They then construct their universe model around these angles, filling in and changing the numbers as needed to fit their assumptions. This is why the spins and orbits are so ridiculous, yet mathematically they work out because it's all based on the angles. And this is also the reason why they changed the distance of the sun over the years to fit their model. This assertion of boats going over the edge of a ball Earth is silly. Check out this footage from a channel called Wide Awake. This guy filmed some great sky and horizon shots showing that objects can be brought back into view, and more importantly, his shots also demonstrate diffraction and the resolution limit of these objects at those distances and at those angles. As you can see in his footage, the boats, once they are close enough to resolve, appear like little smudges, and they also appear to be floating above the horizon. The boats are not mirages floating in the air, although there is an inferior mirage that appears inverted below the actual boats in his footage. To prove this, he actually tracks them all the way in, and the closer a boat gets, the more resolved it becomes, and the more detail you can see. This is a perfect illustration of visual acuity and the angular resolution of the camera, which is obviously better than our eyes, but the principle is the same. And again, if you increase your altitude, say to the top of a hotel or in an airplane or on a mountain, you create better angles and you can of course see further, but even there you will eventually reach a resolution limit. It is unavoidable, but it is not an edge that Santa Claus is falling over. Look at the water in his shots. Some would call the resolved water line the horizon, but you can clearly see boats fully in the water beyond the resolved water line. You can even barely make out the water being sprayed up from the motor. The surface of the water extends beyond the resolved water line, but it is too far and at too sharp of an angle for the camera or your eye to completely resolve. There's also a lot of diffraction going on due to this angle and the light or atmospheric conditions. Therefore, you get a blurred section that reflects the sky and the boat as an inferior mirage. Again, this happens beyond a point where the eye or camera can no longer clearly resolve the water due to the angle and diffraction. It is where your eye or camera can no longer distinguish points of light. The image blurs and turns into a mirror under certain conditions. Look at the shimmering and changing edges of the top of the waterline as the camera resolves it at its maximum distance. Beyond this distance, the water is at too small of an angle to resolve any detail. At this point, it does exactly what a road will do on a hot day. It reflects the light waves like a mirror because the eye or camera can more easily resolve these reflected light rays than they can the actual surface of the road or water. On the ground or on the water, you can see the inferior mirage or reflection of the boats and cars. Some people will claim that the boat itself is a superior mirage and that the actual boat is over the edge of a ball. This is silly for two reasons. Number one, a superior mirage is inverted, and number two, in this footage, he tracks these boats the entire way in, so you can verify with your own eyes how a boat will barely come into view as a small blur, and then as it gets closer and closer, the angles get larger and your eye can then resolve more and more detail. This is observable, repeatable, apparent, and can be verified by anyone, unlike NASA's theories, of course, that nobody can verify unless they can build a little rocket ship. Finally, I would like to discuss the issue of boats or buildings being cut off by the horizon line over water, which many people falsely attribute to the object being over the edge of a ball Earth. Again, I would start by saying that it is easy to debunk this simply by increasing your altitude. If there were a massive drop in curvature obscuring the boat or building, this would be apparent from higher up. Our eyes are not that bad. We can clearly distinguish slopes and hills in the distance, and when you increase your altitude, you can clearly see that the target object lies on the same flat plane as the original observation point. This is simply a function of perspective, angular resolution, and diffraction. When you stand on the seashore, you can see a horizon line, which is basically the limit of your ability to resolve the water, because at a certain distance, the angle becomes too small and diffraction also plays a part. Above this waterline horizon will be everything that your eye can resolve above your eye level. For example, from the beach I can see about 3 to 4 miles of the water's surface, which in my field of view extends from my feet up to my eye level, and it represents my horizon and the limit of my sight up to my eye level. Now, there are hotels located about 18 miles away in this picture, and these hotels are above my horizon line, yet appear to be cut off by the horizon. Not because they are over the edge of a ball, this is simply the point where they fit in due to perspective, where objects that are closer are in front of objects that are further away, which is also a function of diffraction and angular resolution. I cannot resolve the hotels any lower because the angle is too small. If I could resolve the hotels lower, then logically I would be able to resolve more of the surface of the water at a greater distance. But we know this is not possible due to the laws of physics. However, if I were to go up in an airplane, I would be able to see the entire distance from the beach to the hotel, and I could also see that it is flat as a pancake. The hotel is not obscured by the edge of a magic ball. It is simply perspective and angle of view. The limit of what I can see above and below my eye level converge at what we call the horizon line or vanishing point. So check out this little experiment I did. In order to simulate the size and distance of that hotel, I took a small glass bottle and put it on the road and then filmed from ground level. Now the hotel is about 18 stories, which equals about 180 to 200 feet. I used 250 feet just to be conservative and to give it some room above the actual water line, and the distance is 17.5 miles. The glass bottle is 3.5 inches, so that meant that I would have to put it at a distance of about 107 feet to get the same ratio. Now, when I started filming, I was standing up and I could zoom in on the bottle, the entire bottle, top to bottom, and then I pan out, I take the camera and I place it on the ground, and even on the ground it's actually conservative because the lens of the camera is still about 1 inch to 1.5 inches above the ground, so this is a conservative experiment. And when I zoom in, you can see now that the angle of resolution is just too small, and combined with the diffraction, you cannot make out the bottom of the bottle. It disappears. It is cut off. And that is exactly what you're seeing in those pictures and videos where buildings or boats are cut off at the bottom. Your eye cannot resolve the detail of the surface of the ground or the bottom of that bottle. It's just too sharp of an angle. And you can even actually see beyond the bottle where the road is, again, the same color, because your eye can resolve that a little bit better because it makes a curve and the angle is a little bit better on the road beyond where the bottle is. So that's a pretty interesting little experiment and shows you the effect of diffraction and angular resolution. And again, even on the ground, the lens of the camera is about an inch or an inch and a half off the ground, which when you compare that to the bottle, that is almost half of the bottle. So that would probably equal an observer that is about 100 or 150 feet in the air filming the hotel in New Smyrna. So if I was actually on the ground with the camera, I'm sure that the diffraction would probably cover almost the entire bottle, if not half the bottle, and it would look exactly like the waterline covering these hotels or these boats. But you can see the principle. It's verifiable and it's repeatable. So it's an explanation. We don't have to use the Santa Claus falling over the edge of a ball to explain what we see. If I'm standing on the beach at sea level, then obviously my field of view from my feet to the horizon will be much shorter due to the angle. Again, about 3 miles from the beach is approximately the limit for a 6-foot tall individual. Yet the distance of my field of view above the horizon will be much greater due to the angles. Therefore, I can see most of a hotel 18 miles away, but again, not the bottom of the hotel due to the angular resolution and the angle of perspective. The same principle applies to a sunset or a sunrise. The waterline horizon at the beach is about 3 to 4 miles out. Yet the sun is thousands of miles out when it disappears due to the limit of angular resolution and light propagation. We can see the sun at a much further distance because it is so large and high in the sky. But just like anything else, once it gets far enough away from the observer, the angle becomes so small that it will disappear, the furthest edge first, appearing to go down behind the water. This is what you would expect to see based on perspective. Something closer will appear in front of something farther away. This does not mean it is due to a spinning ball Earth. It simply vanishes at the waterline horizon due to perspective. Even the sun is subject to the laws of perspective, angular resolution, and diffraction. With a sunrise, it is the opposite. We see the top of the sun first because it is approaching us. Therefore, the side that is coming toward us is the first section of the sun to come into our field of view due to angular resolution. And again, due to the laws of perspective, the sun will always appear to be behind the much closer waterline. Some will say that it is due to the spin of the ball that you live on, but I think perspective makes more sense, and the sun is simply coming into our field of view due to, again, angular resolution. The problem that truth seekers or flat earthers face when trying to expose lies and deceptions is that most people put their own brains on sleep mode, and they put their trust in the so-called scientific authorities to investigate and explain the reasons for phenomena that we observe from Earth. This is not to say that the scientific community is purposely promoting an incorrect model. What is happening is that everyone is so specialized that they only see a small portion of the big picture. We are basically compartmentalized due to the level of sophistication of technology and our economy. People are also conditioned from kindergarten and throughout school to conform, to obey, and repeat government-sanctioned science. People are conditioned to treat any questioning of the spinning ball Earth as idiotic and primitive. If you mention flat Earth, the reaction is guaranteed to be ridicule, laughter, or even anger at the stupidity of such a statement. No one likes to be wrong, and no one likes to be ridiculed, so there's not much straying from the herd in today's world. I personally believe there's a lot of compelling evidence that calls into question the scientifically accepted model brought to us by the politically created agency of NASA. If everything is exactly how space agencies and government scientists tell us, then we are going to need much more and reliable proof other than CGI images and silly old stories. It is amazing how academia conveniently forgets the debates that used to rage about the rotundity of the Earth, and not by idiots, by learned men and women. So, in closing, I just want to reiterate that There are other alternatives to the theories that were taught to us as fact by space agencies and the political scientific authorities. There are logical and scientifically accepted laws of physics such as angular resolution, diffraction, and perspective, which can be applied in this pursuit. You don't need to be a math genius or have a PhD in physics to understand that there are physical limitations on our ability to see, even with telescopes and cameras. We need to have faith in our own ability to think and use logic and reason. Otherwise, there are many opportunistic groups of individuals who will step in and do the thinking for us. And these groups may not always have our best interests at heart. In fact, they will take advantage and control those who cannot or will not think for themselves. This, I believe, is the modern-day manifestation of slavery, where most people no longer think like humans, they simply repeat and react.
And as I began to think for myself and just look around and use common sense, I began to see things a bit differently. You know, it doesn't take much research online to go find a chart like this on the right that shows what the alleged curvature should be at various miles. And by the way, this is not created by flat earthers. This is created by globers. This is their math. This goes all the way back to Eratosthenes. Their math. 8 inches per mile squared is basically what it comes out to as a rule of thumb. Now, of course, if your observation height is not at ground level, you have to adjust for that. But regardless, I created this little picture right here to illustrate a bit of a problem. According to your math, ballers, the ground below your feet drops off as depicted below. If you're standing on a ball, I mean, this isn't rocket science. If you're standing on the ball, the ground has to immediately begin to recede downward and away from you in every direction from the point upon which you are standing. That's just common sense. You're standing on a ball, it's got to be curving downward and away. So tell us again how you are seeing the horizon at eye level. If you look down on the bottom here, 1 mile, ground level, 0.666 of a foot. It drops off in 1 mile. 2 miles, 2.67 feet. At 3 miles, the drop off is 6 feet. Now, that's ground level to ground level. Okay, let's just imagine a world as a beach ball. All right, the lines of the ball clearly point out what so many in the ball earth camp are blatantly ignoring. A ball, by its very nature, demands that its surface immediately begins to curve downward and away from any point on it. So if we imagine Poser James here, I'm using a software called Poser, let's call him PJ for short. If we imagine him standing on the beach ball, the problem becomes immediately apparent. Okay, he's standing on a ball. Immediately the ball is curving downward and away from his feet in all directions. That's what a ball does. And it doesn't matter how big the person is, nor does it matter how big the ball is. But let's go ahead and shrink PJ and enlarge the ball for the sake of example here. Now, notice the lines are still curving downward and away in all directions, even though he's getting smaller and the ball is getting bigger. This never changes with scale. Okay, now let's zoom into tiny PJ on the massive ball here and consider if PJ was 6 feet tall and he had a clone, who's also 6 feet tall, right, who walked 1 mile away from him, the ground his clone would be standing on would be 8 inches lower than the ground that he was standing on, right? Again, the curvature math is 8 inches per mile squared. So the first mile, 1 times 1 is 1 times 8 is 8 inches. So the ground from point A to point B is going to be 8 inches below point A. All right, you with me so far? Now, if the clone had a clone who walked another mile away, that clone's ground would be 32 inches below PJ's ground. Why? Because it's 8 inches per mile squared. 2 miles, okay, 2 times 2 is 4 times 8 is 32. So the ground that clone number 2 is standing on is 32, almost 3 feet below the ground that PJ is standing on. And if we had yet another clone who was to walk 1 more mile, his ground would be 72 inches or 6 feet below PJ's. Thus, the top of clone number 3's head would be even with the bottom of PJ's feet. If clone number 3's ground is 72 inches below the ground that PJ's standing on, it's going to be physically impossible for PJ to look straight ahead or to the left or the right or behind him and ever expect to see the horizon at his eye level. It cannot be done. I'm going to say it again. If you're just looking straight ahead, there is no way the horizon could ever be at your eye level. When the ground you're standing on is immediately beginning to recede away from you in every direction, you're standing on a point on a ball, supposedly. The ground you're standing on immediately begins to recede away in every direction 8 inches per mile squared. Now, I understand we're not on a perfect beach ball, but you actually compound the problem if you start using the argument, well, there are, peaks and valleys and hills and mountains and plateaus and canyons and blah, blah, blah. All you're doing is pushing the problem further out, and eventually you, the ball earther who uses this argument, are the one who's in danger of falling off the edge of something, because you can extend that out only so far, and then you're going to have to correct the terrain back to that 8 inches per mile squared so that you can have your 25,000 mile circumference ball. Or pair if you choose to go by Neil deGrasse Tyson. And of course, looking at number 3 here, he also deals with sunrise, sunset. And that's a frequent question. How does the sunrise and sunset work on the flat Earth model? Well, I'm sure by now most of you have probably seen this little animation I created. This was done actually back in May of 2015, so it was a month after I first got into this, when I was kind of considering all of it and going, well, I wonder how that would work. And so I created a little animation in Poser, created a point light with a limited throw ratio, so the light is limited as far as how far it'll go, and just animated it in a circle over the circular flat Earth map. But of course, the critics look at this and they say stuff like,
if the sun and moon were just circling over the flat Earth and getting too far away to see, then we would see them shrink and fade out of view as they set. But we don't. Flat Earthers will show you videos where the sun appears to grow or shrink, but this is an illusion due to thick clouds. You can always see that there are clouds near the horizon when they try to show this. Normally, this illusion does not happen.
Oh, so he said that flat earthers are always hiding it behind clouds or whatever. Well, there's plenty of footage out there you can find where there's no clouds involved. This is from a really good video online you guys need to check out called Flat Earth Proof Sunset Off Pucket. I'm not sure if that's exactly how you pronounce it. P-H-U-K-E-T. Really interesting, showing sunset. I believe this was actually somewhere off the equator. Again, you'd have to watch that video for yourself, but it clearly shows the sun changing in diameter as it goes away. So please take note not to ignore this evidence. Other videos you've seen where it looks like it's going in an arc like that and going off into the distance. Other videos where people have taken and used filters and whatnot and analyzed the sun moving and then done measurement of pixels across the screen, showing that it does in fact look like it gets a little bit smaller in some cases. In some cases it gets a lot smaller. In this case from 302 pixels to 290. And then of course there's this video right here, which apparently was shot in the desert where there's going to be a lot less moisture. And so whenever there's less moisture, you're going to obviously have less refraction and magnification.
You don't get to pick the anomalies that seem to agree with your views and ignore the common observations that don't, and still call yourself an honest investigator. That is intellectually dishonest.
So thinking about all this and thinking about what I had just shown you regarding atmospheric lensing, magnification, refraction, all that with regard to cities and objects at a distance on the land, I got to thinking, I wonder how this would work with the sun and moon. So this is what I came up with. I've got my magnifying sheet frame, and I created a little stand to paste the sun on it and keep it the same height over the flat surface of a table. So the sun is always going to be parallel with the surface. And check this out. All right, here's the first test of a sun moving over a flat surface, and with no atmospheric magnification, it does what we might expect it would. It gets smaller as it goes away from us. All right, now let's see what happens when we add in our atmospheric magnification. Again, water and refraction. Water causes magnification and refraction, right? So let's bring the sun back. Oh, check this out. Refraction bends the light downward. It made the sun set on a parallel surface. As it was moving parallel, the same height, the whole way over a flat surface, the refraction caused the sun to set. Not only that, well, let's bring in the beginning of that little test, and we see that it maintained pretty much the same size too. Pretty close. And of course that's because as it's moving away, the magnification is still taking place, and so even though the sun's further away than it was in the beginning of the test, the magnification basically preserved the same size, and the refraction made it set. Of course, again, depending on how much moisture is in the air, we could see that the sun doesn't appear to change in size at all as it goes down. We could see sometimes perhaps that it looks like it's getting bigger when it goes down. You ever see like a really big sunset or moonrise, moonset, you know, where one of them looks really large on the horizon? Well, that could be because there's lots of moisture in the air causing that effect. Or when there's less moisture in the air, obviously you won't have as much magnification taking place, and so it looks smaller as it goes away. So it's all relative to the amount of moisture that's in the air. Now, I'm just going to put forward a crazy idea for you to think about. And that is, if Rob Skiba could figure this out, I'm just going to go out on a limb here. I think it's quite possible that the creator of the cosmos could have figured out the same thing and engineered our beautiful sunsets, thanks to all that water he placed in our atmosphere. Just something to think about. One of the questions that has come up a number of times, actually, is how is it that the clouds can be lit from underneath? Now, in the spinning heliocentric globe model, it's essentially explained that as the Earth is rolling away from the sun, as it's spinning, it rolls such that the sun is at a much lower angle, and because of that angle, the sun is shining up, and the sun rays are hitting the bottom of the clouds. So when you show people the model of the sun going around in a parallel path above the circle of the Earth, they say, well, in that situation, the sun is above the clouds, and so how could it possibly illuminate the bottom of the clouds when it's doing that? So I decided to take up that challenge and see if I could figure that out based on what I had learned in my previous experiments. And so I got one of these stick-em-up LED lights. You kind of push the button and it's got 3 little LED lights inside. And I taped it up so only one of the LED lights is showing and stuck it on a box and put it on the table with my trusty plastic lens set up here. And I took my stand that I was using for the sun and moon and just set it up right here on top of these little Tupperware things. And I was thinking, okay, so let's just say the bottom of this little stand here represents the bottom of the clouds. And so as you can see here, the light is way above, it's well above what would be the bottom of the clouds in this example. So let's see what happens. I turned off the lights and set my iPhone to record, and I'm showing myself here recording all of this with another camera, and I pulled the light back on the table, and watch what happens here. Ooh, check it out. There's that refraction taking place again. It's got the light. It made the sun set, first of all, below the horizon in this case. And let's just show, this is just the iPhone view. I'm going to bring the cloud in here, and the platform represents the bottom of the clouds. So the sun's going down, and oop, there it is. The bottom of the clouds illuminated by a light source that's well above the clouds, moving parallel over a flat surface. So apparently it's possible for the sun to illuminate the bottom of the clouds even on the flat Earth model. Hopefully by now you are seeing that there can at least be more than one way to look at some of this stuff. And as I began to look at things differently and talk about it, I found that there was a growing number of people doing the same thing. And as a result, I was having a lot of very interesting discussions, both privately and through email and, of course, on social media. In fact, early on, back in 2015, someone posted this pic on my wall, and it's a picture of the Denali Range from Kashwitna Lake, available on Wikipedia under the page for Mount Foraker. I'm not sure how you pronounce that. The distance from these peaks is listed as 100 miles. The curvature of a 3,959 mile radius sphere is just under 8 inches per mile squared and commonly accepted as the curvature of a spherical Earth. We simply plug in the numbers. 100 squared times 8 divided by 12 equals 6,666.7. There is supposedly 6,666.7 feet of curvature between the point of this photograph and the mountain range in view. If there was over 6,500 feet of curvature between the photo's point of origin and the mountain range, then Mount Hunter would have roughly 7,000 feet visible, and Denali would have roughly 13,000 feet visible. The curvature would make Mount Hunter appear roughly 53.5% the height of Denali. Creating straight lines from the horizon to the peak of each mountain, the measurements from smallest to largest show 141 pixels, 173 pixels, and 202 pixels. This shows Mount Hunter as exactly 70% and Mount Foraker as 85% the height of Denali. There is only one explanation for this discrepancy. Mount Hunter is actually 70% of the height of Denali, and there is no curvature. You can fact check all of these mathematical equations, heights and distances, measurements, and test them against any large mountain range you wish. The answer is always the same. There is no curvature. Somebody posted that on my wall today, got me thinking about it, and I'm just going to think out loud here. But on a ball, in addition to scaling problems, would not the very distant high mountain peaks have to be arching away from each other toward the left and right instead of appearing straight up and down? Seems to me this is a very good test. Distant mountains sitting on a ball would show all sorts of visual perspective issues, from scale to angle problems. Yet anytime I've ever seen a distant mountain range, it always looks like the mountain peaks are appropriately scaled and in a straight line, going out as far as the eye can see. The fact that the horizon never drops below eye level is also problematic for believers in the globe. The higher up you go, the more you should have to drop your line of sight downward in order to see the horizon. But this is never the case, even at altitudes above 60 miles. And I've got a video here, a little animation that I did showing like a hot air balloon going up over a very large ball or going up over a very large plane. And as it goes up over the plane, the horizon always stays the same. It stays at eye level. But if you were rising up over a ball, that would not be the case. The higher up you go, the more you should have to adjust your eyesight, your eye line, downward. You have to tilt your head to look down toward the horizon as the ball recedes away from you underneath you. And I say in this animation, so then the question is, which illustration best fits what we always see? And really, I mean, you see that that's the case even to altitudes up to 160 miles in some of these other videos I did here. I'm not going to play them here, but you can check them out for yourself. Well, actually, I'll play this one. This one's short. In my blog series at testingtheglobe.com, I've shown that the alleged curvature is not even detectable at 120,000 feet when people send up weather balloons with cameras not fitted with a fisheye lens. And by that I'm talking about, there's some videos that I have on my website there, and you can do videos yourself, do some searches on YouTube for videos of people doing high altitude weather balloon tests where they're sending up weather balloons, and if they have it fitted with a camera that doesn't use a fisheye lens, I mean, that thing's going up to 120, 121, 127,000 feet and spinning in 360 degrees and showing the horizon flat as a pancake, as opposed to the Red Bull video or, you know, typical NASA video, which is always, it seems like always shot with a fisheye lens. And that's easy to tell when they're using a fisheye lens. First of all, like in the Red Bull deal, when that dude gets out of the capsule and stands out and they cut to the camera outside looking at him, the curve of the Earth is so ridiculous, the size of the planet would have to be less than that of the moon. And that dude would have to be jumping from like millions of miles away, or at least hundreds of thousands of miles away. I mean, the curve is just insane. And whenever the camera tilts at certain angles, I mean, it goes from convex to flat to concave to flat to convex to you know, it's going all over. It's an incredible morphing Earth. That's what happens when you use a fisheye lens. And a lot of the cockpit footage that I've seen from like this Russian MiGs and stuff that people are sending me that get up there really high, same thing. In fact, you can look in one of the shots over the pilot's shoulder there. The wing is all warped because of the curvature of the windshield. So yeah, we got to be careful with curved lenses or glass that we're looking through. And that's why, for me, I've basically had to just throw most of that stuff out because it's inconclusive at best. Because you look at one and it says, oh, well, there's a curve. And you look at another and it says, well, no, there's not a curve. You know, same altitude. And speaking of altitude, here's an interesting video done by Steve Torrance where he was looking at a lot of the high altitude balloon launches that were taking place, and for the most part, people are getting up to between 100 and maybe 130,000 feet max. And as I've said many times before, you can't rise off of a ball and expect the horizon to rise with you. Well, he is a very high-end computer graphics guy, and he created a scale representation of the globe versus a scale representation of the flat disk, and took it and modeled it with a 36 millimeter camera with no fisheye lens effect on it, and made the camera rise to 25 miles or approximately 130,000 feet, which is pretty much the ceiling for people that civilians anyway that are doing high altitude balloon launches. And this is the results of what he did. Again, this is a perfectly scaled representation of a 25,000 mile circumference ball versus a flat disk. I'm not sure what the circumference was of the disk that he modeled, but a flat plane nonetheless. And you know, you can see if you're rising up off of a ball, the horizon, of course, has to drop significantly. And then at the very end of the video, he says, okay, you know, which one do you think better represents the original? The flat model or the globe model? Well, I think the answer is pretty obvious for anybody who's seen footage shot from a weather balloon. Now, as far as the argument of, well, not only would you see Chicago from the other side of Lake Michigan, you would also see the Rockies. Well, yeah, if there was no atmosphere or other obstacles, buildings and stuff in between, that's a patently absurd argument. There's lots of things in between Chicago and the Rocky Mountains. All right. So that's not really a good reason. And here's just a few points from Eric Dubé's 200 Proofs Earth's Not a Ball video book to further drive the point home concerning issues of the alleged curvature.
1. The horizon always appears perfectly flat 360 degrees around the observer regardless of altitude. All amateur balloon, rocket, plane, and drone footage show a completely flat horizon over 20 plus miles high. Only NASA and other government space agencies show curvature in their fake CGI photos and videos. 2. The horizon always rises to the eye level of the observer as altitude is gained, so you never have to look down to see it. If Earth were in fact a globe, no matter how large, as you ascended, the horizon would stay fixed and the observer would have to tilt looking down further and further to see it. 3. The natural physics of water is to find and maintain its level. If Earth were a giant sphere tilted, wobbling, and hurtling through infinite space, then truly flat, consistently level surfaces would not exist here. But since Earth is in fact an extended flat plane, this fundamental physical property of fluids finding and remaining level is consistent with experience and common sense. 4. Rivers run down to sea level, finding the easiest course, north, south, east, west, and all other intermediary directions over the Earth at the same time. If Earth were truly a spinning ball, then many of these rivers would be impossibly flowing uphill. For example, the Mississippi, in its 3,000 miles, would have to ascend 11 miles before reaching the Gulf of Mexico. 5. One portion of the Nile River flows for 1,000 miles with a fall of only 1 foot. Parts of the West African Congo, according to the supposed inclination and movement of the ball Earth, would be sometimes running uphill and sometimes down. This would also be the case for the Parana, Paraguay, and other long rivers. 6. If Earth were a ball 25,000 miles in circumference, as NASA and modern astronomy claim, spherical trigonometry dictates the surface of all standing water must curve downward an easily measurable 8 inches per mile, multiplied by the square of the distance. This means, along a 6-mile channel of standing water, the Earth would dip 6 feet on either end from the central peak. Every time such experiments have been conducted, however, standing water has proven to be perfectly level. 7. Surveyors, engineers, and architects are never required to factor the supposed curvature of the Earth into their projects. Canals, railways, bridges, and tunnels, for example, are always cut and laid horizontally, often over hundreds of miles without any allowance for curvature. 8. The Suez Canal, connecting the Mediterranean with the Red Sea, is 100 miles long without any locks, making the water an uninterrupted continuation of the two seas. When constructed, the Earth's supposed curvature was not taken into account. It was dug along a horizontal datum line, 26 feet below sea level, passing through several lakes from one sea to the other, with the datum line and the water's surface running perfectly parallel over the 100 miles. 9. Engineer W. Winkler was published in the Earth Review regarding the Earth's supposed curvature, stating, "As an engineer of many years' standing, I saw that this absurd allowance is only permitted in school books. No engineer would dream of allowing anything of the kind. I have projected many miles of railways and many more of canals, and the allowance has not even been thought of, much less allowed for. This allowance for curvature means this, that it is 8 inches for the first mile of a canal and increasing at the ratio by the square of the distance in miles. Thus a small navigable canal for boats, say 30 miles long, will have, by the above rule, an allowance for curvature of 600 feet. Think of that, and then please credit engineers as not being quite such fools. Nothing of the sort is allowed. We no more think of allowing 600 feet for a line of 30 miles of railway or canal than of wasting our time trying to square the circle. 10. The London and Northwestern Railway forms a straight line 180 miles long between London and Liverpool. The railroad's highest point, midway at Birmingham Station, is only 240 feet above sea level. If the world were actually a globe, however, curving 8 inches per mile squared, the 180-mile stretch of rail would form an arc with the center point at Birmingham raised over a mile, a full 5,400 feet above London and Liverpool. 11. A surveyor and engineer of 30 years published in the Birmingham Weekly Mercury stated, "I am thoroughly acquainted with the theory and practice of civil engineering. However bigoted some of our professors may be in the theory of surveying, according to the prescribed rules, yet it is well known amongst us that such theoretical measurements are incapable of any practical illustration. All our locomotives are designed to run on what may be regarded as true levels or flats. There are, of course, partial inclines or gradients here and there, but they are always accurately defined and must be carefully traversed. but anything approaching to 8 inches in the mile, increasing as the square of the distance, could not be worked by any engine that was ever yet constructed. Taking one station with another, all over England and Scotland, it may be stated that all the platforms are on the same relative level. The distance between eastern and western coasts of England may be set down as 300 miles. If the prescribed curvature was indeed as represented, the central stations at Rugby or Warwick ought to be close upon 3 miles higher than a cord drawn from the two extremities. If such was the case, there is not a driver or stoker within the kingdom that would be found to take charge of the train. We can only laugh at those of your readers who seriously give us credit for such venturesome exploits as running trains round spherical curves. Horizontal curves on levels are dangerous enough. Vertical curves would be 1,000 times worse, and with our rolling stock constructed as at present, physically impossible. 12. The Manchester Ship Canal Company, published in the Earth Review, stated, "It is customary in railway and canal constructions for all levels to be referred to a datum which is nominally horizontal and is so shown on all sections. It is not the practice in laying out public works to make allowances for the curvature of the earth." 13. In a 19th century French experiment by MMBO and Arago, a powerful lamp with good reflectors was placed on the summit of Desierto las Palmas in Spain, and able to be seen all the way from Capri on the island of Ibiza. Since the elevation of the 2 points were identical and the distance between covered nearly 100 miles, if the Earth were a ball 25,000 miles in circumference, the light should have been more than 6,600 feet, a mile and a quarter, below the line of sight. 14. The Lieutenant Colonel Portlock experiment used oxyhydrogen Drummond's lights and heliostats to reflect the sun's rays across stations set up across 108 miles of St. George's Channel. If the Earth were actually a ball 25,000 miles in circumference, Portlock's light should have remained hidden under 1.5 miles of curvature. 15. If the Earth were truly a sphere 25,000 miles in circumference, airplane pilots would have to constantly correct their altitudes downwards so as to not fly straight off into outer space. A pilot wishing to simply maintain their altitude at a typical cruising speed of 500 miles per hour would have to constantly dip their nose downwards and descend 2,777 feet, over half a mile, every minute. Otherwise, without compensation, in 1 hour's time, the pilot would find themselves 31.5 miles higher than expected.
And here we are with the airplane example. Wow. I mean, I can't tell you how many people, when I first got into this, even today, people are still saying this. Oh, if you ever flown in an airplane, you've seen the curve. Well, no. You might think you have because you've been programmed to believe that you have. But get in a plane. Take off. Watch the horizon rise with you. Something that's impossible to do on a ball. But the horizon comes up with you. Then take a picture with a camera that doesn't have a fisheye lens. Go home, put it in Photoshop, put a parallel bar over it. Guess what you're going to find? Flat as a pancake. And I know D. Marble's video got a lot of attention when he took spirit level with him. I actually did the experiment before he did, several months before. In fact, the previous year, 2016, I put out the challenge after watching the Max Egan video that Jeranism did. At the end of it, I said, whatever assumption you start with, you have to admit it is very interesting that the on-screen display says that they are on a northwest heading, which is what you would expect if you just flew up from under the ball, headed towards Sydney. Yet Max Egan has this compass sitting on his tray showing a heading of southwest. Things that make you go, I'm very intrigued by this. If there's anybody out there who can make this flight and document it, I'd like you to do two things. Confirm what Max Egan did by bringing a compass with you on the flight. Do the same thing he did, bring a compass with you. Please use a better camera so you can actually hear what's going on and it's not so herky-jerky. Use your iPhone or something like that. So document it as best you can. And I would say also bring a spirit level with you. I'm not going to get into it in this video right here, but that would determine whether or not you are flying straight and level. Now, of course, I know that you will be flying straight and level because that's what pilots do. But that's not possible on a ball. You cannot use your attitude indicator set to level and fly 500 plus miles an hour over a ball without significantly increasing in altitude about every 12 minutes. This is because at 500 miles per hour, every 12 minutes or so, you'd be going about 100 miles. In fact, according to the Pythagorean formula for calculating curvature, in 1 hour's time, this is how much altitude you should accumulate if flying straight and level. Unless you be tempted to say attitude indicators don't work that way and that they do, in fact, adjust for the curvature using that magical Tony the Tiger force of gravity. See the description below for a couple of videos that debunk that idea. Anyway, here's my challenge to anyone willing to take me up on it. Bring a compass, a good camera, and a spirit level, and if somebody out there can make this flight and document it, do what Max Egan did, send me the video. I'd love to see it. That would be something really cool to check out.
So, taking on his cue, I brought my compass on this flight. And I brought my there's a digital compass on the phone that also has a digital level, and I brought a spirit level. Things didn't happen that should be happening.
Okay, so here you see my spirit level, and here you see both my phone and my wife's phone. We have the compass app that also has a level on it, and as I was tilting it right there, you can see how it works. It shows negative, up or down, if it's tilting forward or backwards. Got my compass out here, put it next to the two phones that I had right here. I'm using both phones to kind of double check with two sources. I decided not to have my level nearby because it has a magnet on it and it could be causing a problem for the compass, so I stashed that away in my luggage so it's not going to cause a problem. And so I recorded it actually separately. What you see in the top left corner here is a video I shot of about 15 minutes worth of just the spirit level. I got rid of everything else, so it's just the spirit level sitting on my tray table, and I recorded that for 15 minutes. And then separately, the video below that here is with the two iPhones and the level app on those phones with my compass, and I recorded that for about 15 minutes. So other than some minor turbulence here and there causing it to switch to about -1, I think was the most I saw as far as it changing its level, they both stayed in the green at 0. So, I mean, here's two tests I did. One with just a spirit level for 15 minutes, and one with two iPhones using the same app, just to make sure both of them are working right. Every now and then I had to tap my phone and my wife's phone because it wanted to go into sleep mode. But otherwise, there you have it. So at no time did the plane ever show any indication of going into a nosedive as you would expect that it needs to when you're flying over a ball. And I know there's people going to argue against that. And that's, I'll make another video that deals with that issue. Oh, gravity is taking care of the whole situation. No, it's not. You don't understand how a gyroscope works. But again, that's a whole other video. Right here, you see the on-screen display showing our speed, showing the path we're taking. In the top right, I've got a freeze frame of that. You show the circle of the Earth navigation from Minneapolis to Amsterdam, which on the flat Earth map is a straight line. So there you go. And again, I'm just kind of going back and forth with my camera, just kind of showing. Tapping the phone again because it's want to go into sleep mode. The compass gave pretty much an accurate reading the whole way as I expected it would in the northern hemisphere. I expected it to show an accurate representation of our flight path, both on the circle of the Earth navigation as well as the straight line on the circle of the Earth. So that's no surprise to me. The Max Egan one isn't really a surprise either if you subscribe to the circular flat Earth model. His reading's exactly what you would expect it to be, but not what you would expect it to be if you're looking at the on-screen display in the circle of the Earth navigation. So that's why I wanted to show that clip, before this one. Again, there's a lot more to talk about. I don't have the time to do it with this video right here. I just wanted to get out because a lot of people were asking me what happened. People saw the picture that I posted on Facebook saying, hey, I'm all set, ready to go on my flight. I got my compass, my level, and ready to do some tests on the flight. And so since people have been asking me over and over and over again, what were the results? What were the results? I decided just to put this video together. Maybe at some time in the future I'll do another video that will explain the issues of the avionics, the attitude indicator, the altimeter, the airspeed indicator, and how a gyro works, and show that the whole idea that gravity is keeping the plane level is utterly ridiculous. We should be having to dive down. Actually, we're going faster than 500 miles an hour. The calculation I had where it said that we should have to either take a nosedive every 12 minutes to 1.26 miles or show an increase in altitude of 1.26 miles, or what is that? About 6,653 feet every 12 minutes. Now, again, that calculation is based on going 500 miles per hour, but as you'll see on the on-screen display, we were going closer to 600 miles an hour. So we would have that problem in less than 12 minutes. I'm not going to do the math out here. Somebody else can do that if you feel so inclined. But at any rate, as I monitored the altitude, I never saw much more than a very minor fluctuation, maybe 5 or 10 feet or something like that, which could be accounted for with updrafts and turbulence and things of that nature. So never saw a dramatic increase of altitude, which you should see if you're flying straight and level, and all of the instruments that I had were showing that we are flying straight and level. I'm sure in the cockpit the attitude indicator was showing that too, because that's how a pilot flies. He's always monitoring. I mean, he's got lots of instruments to monitor as well as radios and stuff like that, but 3 instruments that you're really paying a lot of attention to when you're flying is the airspeed indicator, the attitude indicator, and the altimeter. And they really work together, because if you're all of a sudden noticing that you're increasing in airspeed, there's a pretty good chance you're probably in a dive. If you're decreasing in airspeed, there's a pretty good chance that you're in a climb. And or if you're looking at the attitude indicator and you're seeing, well, I'm in a climb or I'm in a dive, you'll notice that in your airspeed indicator as well as in your altimeter. So these instruments would be in conflict with each other if you're flying over a ball. If you are focused on keeping your airspeed the same and keeping your attitude the same, i.e. keeping the horizon perfectly level, in both to your eyes if you're able to see the horizon out the window, as well as to the attitude indicator itself. If you're keeping that plane straight and level, flying straight and level and maintaining airspeed, then your altimeter, if you're flying over a ball, must show an increase in altitude. And I'm sorry, gravity's not going to save you. So anyway, I'll just go ahead and let this play the rest of the way. I recorded for about 15 minutes twice. Again, once for just the spirit level, and again with the 2 iPhones and my compass. And I took both tests, put them here on the screen for you to watch both tests at the same time. And well, you'll see. We'll just let it play out for 15 minutes, and you'll see that there was no change whatsoever. Brought a compass, a spirit level, and I used the compass app and the level app in the my wife's iPhone and my iPhone. So I had like double and triple check tests going on at the same time. Had a nice long flight to do it on too. And yes, it is true that pilots fly the Great Circle navigation. The Great Circle, yes. Because what it does is it creates an artificial equator, because the shortest distance between 2 points is a straight line. So that's forcing a straight line, bisecting the ball into 2 hemispheres, basically. But what's interesting is, like when I did the flight to Amsterdam, this was the path that I took. Okay. And we're going over to Amsterdam. We're going to go up over Greenland like this. Interesting thing, on the circle of the Earth, it's a straight line. kind of cool. So yeah, but I mean, this is the other problem, is if you're flying in a commercial airliner at 500 miles per hour, you'll be flying at about 8.33 miles per minute. 8.33 times 60 minutes equals 499.8 miles in an hour. Thus, at 8.33 miles per minute and times 12 minutes, you will travel 99.96 miles. So, for example, rounding up to 100 miles, in the first 12 minutes, the expected curvature below you is 1.26 miles. And it just keeps getting exponentially higher and higher as you go. So if you have an attitude indicator, which tells you if you're turning left or right or diving or climbing, and you have an airspeed indicator and an altimeter, three very important instruments that pilots are always scanning. And if you got your plane trimmed for level flight, and the gyro is spun up inside and the airframe is caged to the gyro, the function of the gyro is to maintain rigidity in space apart from gravity. If it was dependent on gravity, stunt pilots could never do what they do. Pulling the G's and doing all this, they can never rely on their instruments because all their instruments would be completely jacked up due to gravity. The function of the gyro is to maintain rigidity in space apart from gravity. So if you've got your airframe caged to the attitude indicator gyro on the flight line at level, then when you're flying and you trim your flaps and everything, your controls for straight level flight, and your attitude indicator shows that it's right across the horizon, is going right across the center of the gauge. You're not climbing, you're not diving, you're not turning left or right. It's level, and you're maintaining a constant speed. If you keep your airspeed at 500 and your attitude indicator straight and level, then your altimeter must begin to register 1.26 miles in the first 12 minutes, and it keeps going higher and higher and higher from there. 60 in 36 minutes, 60,086 feet. You should be above the ground, and eventually you just shoot out in space. And people try to use the argument, well, there's like a gravity holding onto the bottom of the plane, and it's like tied to a rope, and it's maintaining level. Sorry, that doesn't work with the gyro.
The following is taken from the most recent edition of the Federal Aviation Administration's publication, The Pilot's Handbook of Aeronautical Knowledge, Chapter 7, page 15. There are two fundamental properties of gyroscopic action: rigidity in space and precession. Rigidity in space means the gyroscope remains fixed in the plane in which it is spinning. Thus, if the gimbal rings are tilted, twisted, or otherwise moved, the gyro remains in the original plane. Rigid in space. Let's watch a few gyros in action. Up first is a video produced by the United States Navy in 1960, used to train pilots on the mechanics of their flight instruments.
To understand any gyroscopic instrument, you must understand the principle of the gyroscope. It consists of a rotor mounted in a gimbal. The rotor can spin in one plane only. When another gimbal is added, a second plane of movement is possible. And when this assembly is mounted in bearings, the rotor has three planes of movement and can assume any possible attitude. This is now a freely mounted gyroscope. A spinning gyro has two important properties: precession and rigidity in space. All of its practical applications are based on these two properties. As for rigidity in space, the spinning rotor remains in its original attitude, while the gimbals and base move around it. In other words, the gyro maintains its axis in relation to space and not to the surface of the Earth. If a gyro moves around the Earth, its axis is vertical to the Earth's surface here, at an angle here, and horizontal here.
The spinning wheel prefers to stay oriented as it is, and it resists any attempt to change that orientation. The fact that gyroscopes will maintain a particular orientation in space is very useful. In modern aircraft, an inertial guidance system uses spinning gyroscopes to monitor and control the orientation of the aircraft. The gyroscope is suspended in a special cage that allows it to maintain its orientation independent of the aircraft's position.
An attitude indicator, also known as an artificial horizon, is an instrument used in an aircraft to inform the pilot of the orientation of the aircraft relative to Earth's horizon. It indicates pitch, fore and aft tilt, bank, side-to-side tilt, and is a primary instrument for flight in instrument meteorological conditions. Pilots must rely on this instrument in order to maintain control of the aircraft during flight in IMC.
Each instrument continuously indicates the roll and pitch attitude of the aircraft in relation to the actual horizon, and each obtains this information from a freely mounted gyro. The axis of the rotor is vertical and, due to the property of rigidity, will remain in this position as the aircraft assumes any attitude. Therefore, the gyro establishes a vertical reference from which roll and pitch deviations of the aircraft can be measured.
Another excerpt from the pilot handbook states, "The gyro is mounted in a horizontal plane and depends upon rigidity in space for its operation. The aircraft actually rotates around the spinning gyro." Now that we have a fundamental understanding of how the gyroscope and attitude indicator works, let's contemplate an intriguing and quite contradictory scenario. A scenario that occurs every single day during every single flight. When an aircraft takes off, climbs to its final altitude and levels off, the attitude indicator depicts a perfectly level attitude. As the aircraft travels towards its destination, sometimes in excess of 7,000 to 8,000 miles, the aircraft's attitude indicator maintains a perfectly level attitude. This, as we have seen, cannot be correct, because the gyro maintains its original position in space, regardless of the aircraft's attitude, or its position on the Earth. According to known gyroscopic properties, a pilot flying by reference to his attitude indicator should in reality begin to fly away from the Earth, as the gyro will continually give a straight line from the plane in which the aircraft started. Again, it is stated that the attitude indicator is reliable and the most realistic flight instrument. It gives an instantaneous indication of even the smallest changes in attitude, and, since the gyro relies on rigidity in space, the aircraft actually rotates around the spinning gyro. Therefore, we can logically only conclude two answers to our problem. Either A, the gyroscope operates on a set of properties unknown to modern physics, in which case, many aircraft must be susceptible to potential errors from an instrument we truly do not understand. Or B, our world is not what we have been told. The curvature of the Earth is not what is claimed by NASA, nor is it curved much at all, lest the gyroscope would read inaccurately during every flight. One can only conclude that the gyroscopic properties are fundamentally true, and therefore the world in which we live has a few more questions that need answering.
Gyro's job is to maintain rigidity in space apart from gravity, independent of gravity. I mean, if gyros are subject to the same forces that humans are, well, when you talk about G-forces, you're pretty much screwed. if the gyro is reacting to gravity like this, it's not a very reliable instrument. And perhaps that's why NASA has, I mean, you could go to NASA websites and see for yourself where they have documents like this right here. You click on that, it takes you to a PDF. It's of a document called The Derivation and Definition of a Linear Aircraft Model. NASA reference publication 1207, published in 1988. You can scroll down to the opening statements. Summary: this report documents the derivation and definition of a linear aircraft model for a rigid aircraft of constant mass flying over a flat, non-rotating Earth. The derivation makes no assumptions of reference trajectory or vehicle symmetry. The linear system equations are derived and evaluated along a general trajectory and include both aircraft dynamics and observation variables. And you can scroll through this document, and most of this is aviation mathematics and things of that nature. A lot of math going on here. And scroll down to page 30, concluding remarks. This report derives and defines a set of linearized system matrices for a rigid aircraft of constant mass flying in a stationary atmosphere. In other words, the atmosphere is not being velcroed to the Earth, traveling 1,000 miles an hour, over a flat, non-rotating Earth. So they're saying it again in the concluding remarks. And you can find another document that's similar to that one at the FAA.gov website. You can probably read this long URL here if you're interested. And you can scroll down to page 32. Somewhere thereabouts. Yeah. The observant reader will notice that the aircraft equations of motion were calculated assuming a flat Earth, and that we here assume the development frame was the northeast down frame. This implies necessarily that Earth rotation and the variation of gravity vector with position over the Earth were ignored in developing the aircraft equations of motion. Okay, we're talking about high-performance aircraft traveling at or below Mach 3. And yet all of their equations are based on a non-rotating flat Earth? And someone will say, well, that just simplifies the math. Well, it also could just be that you can't fly the way they say you're going to fly if you're flying over a ball. I mean, this is the FAA and NASA saying that they create their aircraft performance analysis based on a non-rotating flat Earth. Go figure. And this is perhaps because of all the reasons that I've been talking about here so far. So D. Marble did his spirit level test. I did my spirit level tests. I'm sure there's probably others out there that did spirit level tests as well. And I found this video here by Paul on the Plane where he's talking about a fairly recent test he did back in September 2017 or August using a bubble level app on his phone. I guess this is, I think, the second or third time he's done it, actually. Check this out.
So today's video is a little experiment I conducted last month while traveling on business. I was back in Lake Tahoe. Many of you may remember the 18-mile convex water experiment on Lake Tahoe. I think it was last March, from which I drew the conclusion that either the Earth is much larger than we've been told, or it's generally flat. No, I didn't find any water curving over the 18 miles, even though the pictures of Tahoe we get from quote-unquote space that we are given show major curvature. So there's two casinos on the South Shore that stand about 200 feet high, and I was able to see them from 18 miles away with my Nikon P900. So yeah, do the math. I shouldn't have been able to see them. But I digress. Okay, so this experiment is another bubble level app experiment. And yep, I'm the guy who flew from Seattle to Ireland last June to test the alleged curvature with the bubble level app and found that there was no curvature. We flew over a flat, fixed Earth many thousands of miles. I also did a video driving about 200 miles to measure curvature with the app and, of course, failed to find any. It's funny how everyone who goes out attempting to measure curvature is unable to. Huh. Crazy, eh? Okay, but back to the bubble level app on our smartphones. It's funny how many people still think that the bubble level app, which unlike a traditional bubble level can be locked at any orientation, at any angle or degree, and that they think it would not show a change in the bubble, especially over so many miles. They simply don't get how the technology works, I guess. We should be able to lock the orientation of the phone in free space with the bubble level app and slowly see the bubble move off center over a period of even 30 to 60 minutes as the alleged spin of the Earth happens. You globe defenders do get that, right? I mean, the phone is locked into a certain orientation in free space, so any movement of the phone will register a change in the bubble. Any movement of the phone's angle will register a change in the bubble. Think about that some more. Okay, so many people have even proven that the phones are sensitive enough to measure the Earth's spin, but it's funny how the spin never is registered. Okay, I digress. Again, So I got a lot of feedback on my Seattle to Ireland video that since I was flying west to east and the Earth allegedly rotates east to west, that I simply flew, quote-unquote, into the spin and stayed relatively on the same latitude, even though I flew a lot farther north, that the bubble level app didn't register a change because I was relatively in the same position as when I left Seattle some 15 hours earlier. Kind of a stretch, but it seemed to be a common theme that I was getting. Even the awesome Jaren from Jarenism on Globebusters, on a Globebusters episode a week or so later, commented that he'd like to see the same experiment done on a trip north to south or south to north, so that argument could not be used. Well, that's the experiment that I conducted here. I was flying from Reno, Nevada to Seattle, Washington, which is clearly a south to north route, as you can see here on the map. So there's no chance that I flew into the alleged spin or could be in the same relative position after the 2.5-hour flight between the two airports. Okay, so here was my results. I took a screenshot of the bubble level app sitting on the plane in Reno, and you can see the time date stamp here, and the other screenshots I took showing the altitude and the latitude and longitude from the two apps to confirm my position on this flat, fixed plane that we live. So these coordinates will show you that I was here when I took the first measurements. And then a few hours later, when I landed in Seattle, I did the same thing. I took a screenshot of the bubble level app, and as you can see, no change. It should have been off by at least a few degrees. I mean, considering I flew approximately 563 miles, and Seattle should be about, 211,000 feet or so below the horizon, or about 40 miles, when I'm sitting in Reno. Yeah, I should see a few degrees there, guys. And here were my coordinates sitting on the runway in Seattle after landing, where I took the second and final measurement. So, there you have it. My first two experiments were west to east and east to west, so here is an experiment traveling the alleged globe south to north. But, unfortunately for you globe defenders, that darned elusive curvature was not found again. When is someone going to be able to measure that darn thing, huh?
And that's the real issue, isn't it? There was a video going around a while back with this guy that had an interesting accent. Where's the curvature? If you can't measure curvature, then maybe there isn't one to be measured. There are a lot of people out there, just regular people, getting in boats and using lasers and buying the Nikon Coolpix P900 camera and going out and doing tests for themselves. That's what I've done, and a lot of other people have been doing the same thing. I mean, why do you think there are so many people all around the world all of a sudden becoming flat earthers? Could it be that maybe they're seeing things for themselves? I'm going to suggest that they are, because that's what happened to me. So, again, I don't those who don't want to believe aren't going to believe anyway. This isn't for them. This is for those of you who are out there who have questions, that are seeking answers, legitimately seeking answers. And I'll just put a challenge out to you. If you want to try to prove this issue of curvature in the horizon, go get some lasers, get a Nikon Coolpix P900 or a good telescope binoculars, and just start going out and looking at things for yourself. So for me, number 3 just isn't a good proof for the globe.